Department of Physics. And in the previous class, we have studied about waves and how the waves are being formed and what are the different characteristics of the waves and what are the different types of waves. And I want to just give a recap of the previous lecture so that before we enter into this lecture, I'll be giving a recap of that. In the previous class, we have seen that waves are three different types. Basically, we have seen first one is a mechanical wave or the elastic wave, and the second one is nothing else but the electromagnetic wave, and the third one is a matter wave. The first one, mechanical wave, we know that this is a wave which definitely requires a medium for the propagation of the waves. And secondly, if I come to the electromagnetic wave, these are the waves which does not require a medium to propagate, but it can even propagate in a vacuum. And examples of this electromagnetic waves, we have seen a visible light as one of the example, ultraviolet rays, infrared rays, radio waves and microwaves are a few of the examples of the electromagnetic waves. And the next one, when you come back to the third one, is the matter waves. In the matter waves, we have seen that this is a wave which is mainly produced due to the motion of the particles like electron, proton, neutron, or subparticles like atoms and molecules which are very minute in nature. So whenever these particles move from one point to another point, their motion will cause these waves. These waves are nothing else but the matter waves. And next we can also say that it's not regarding the motion of the particle. We can also say that matter wave is a wave which is mainly produced with the collision of these particles like electron, neutron, or proton. Whenever this particle collide, then a wave has been formed or a motion has been formed. That motion we call it as a matter wave. Now coming back to the next type of the wave, which is called as a gravitational wave. First one, you have seen the types of wave. The first one is a mechanical wave, and second one we have seen electromagnetic wave, and third one is the matter wave. And now coming to the fourth part, which is nothing else but the gravitational wave. Now, what is meant by gravitational wave? We all know that all the celestial bodies, even including the Earth, will be bonded to each other or bonded with a kind of force, and that force we call it as a gravitational force. So now here, gravitational force, the gravitational wave is nothing else but it's a wave which is mainly associated due to the motion of the celestial bodies. It can be even Earth. And the examples of the celestial gravitational wave can be like whenever the asteroids are falling from the sky. You can say that the asteroids, whenever they move out of their orbits, then definitely they provide or they produce a kind of motion. That motion we call it as a gravitational wave. So the definition of this gravitational wave can be the wave or the disturbance, the wave or the periodic disturbance which is produced due to the motion or movement of celestial bodies is called gravitational wave. Examples. See, we all know that whenever even Earth moves or whenever there is some kind of disturbance in the Earth, the volcanoes will be erupted. So one of the examples of this gravitational wave can be eruption of volcanoes. And the next can be, as we have just learned, the next can be asteroids falling from space when they move out of its orbit. when they move out of its orbit. So here we can say that there are the types of waves are nothing else but first one is a mechanical wave, electromagnetic wave, matter wave, and the fourth one is a gravitational wave. The gravitational wave, we have studied that it's a wave or a periodic disturbance which is produced mainly due to the motion or movement of a celestial bodies. An example is nothing else but the eruption of volcanoes can be one of the example. Another one is asteroids falling from the space. That's nothing else but when they fall from the space, they move. Due to that motion of the asteroids, this kind of waves have been formed. So these are the few different types of the waves. Kindly, if you want to note it down, please note it on this particular topics. So let us see now the next concept called wave motion. So I want to explain this concept of wave motion by taking one example. So first I'll consider there are two fixed ends. Let the two fixed ends be point A and point B, and between these ends I have connected a string. You can also call it as a spring, whatever it may be. You can take a string or a spring. Now, whenever I connect a string or spring in between the point A and point B, which are the fixed ends, then if you try to disturb the stableness, or if you try to disturb the stillness of the spring, what happens? Let me say I have disturbed at this point. If the disturbance has taken place over this point, then what happens? Then the disturbance will be traveling on either sides of this string. Such a way, this travels like this. So whenever you disturb the string, then the disturbance of the string or the motion of the string will be happening in this way. So there will be an up and down in the nature of the position of the string. So then once what happens? Whenever the string strikes the ends of this one, then again it comes back. Then again it comes back. So one of the position can be once the string goes in this direction, then later it comes back in this direction. So what has happened here? Whenever we have disturbed the string, there is a continuous motion in the string. So we can say that the wave motion is nothing else but it is a continuous disturbance in a particular medium or the medium's particle. So now we can define the wave motion as the continuous disturbance in the particles of the medium by maintaining the continuous periodicity in the disturbance, periodicity of the disturbance. So let us see the definition of this one. The definition can be it is a continuous disturbance in the medium particles by maintaining continuous periodicity of disturbances. So just now we have seen that whenever you strike a string, the particles in this medium will be moving continuously. How can I say that these particles are moving continuously? So see now, once if you strike a string, until the string comes back to its original position, it will be in a motion. So the motion of the string will be upside down. So once if it goes and touches this end, then again the movement of the string in upside down will come back. It will reflect back in the opposite direction. So continuously it goes ups and down until the string comes back to its original position. So that's why on this basis we can define the wave motion as it's a continuous disturbance in the medium particles by maintaining the continuous periodicity of the disturbance. Now what is meant by periodicity? Coming to the periodicity, it is a fixed time. Fixed time of what? Here the particles which are moving here will be the particles which are moving over here will be always have to disturb or should maintain a equal amount of time between each and every disturbance. Means what? If a particle has started at this point, again the same amount of time should take again to come back to this position. Okay, if the up has taken some n number of seconds, then again the second up of this particular wave should be same. So that's why the fixed time periodicity means it's a fixed amount of time which is taken by the particle between one disturbance to another disturbance. So this is called as a periodicity, and the definition of wave motion is nothing else but it is a continuous disturbance in the medium particles by maintaining continuous periodicity of a disturbance. Periodicity means it's a fixed time. So the next concept, if I consider about the next concept, if a particular wave motion has to happen in a medium, then what should be the characteristics of the medium? If a wave motion has to happen in a medium, then firstly the medium has to be elastic in nature. It has to be elastic in nature. The first characteristics will be medium to have it should be elastic in nature. The next one, all the particles which are disturbed or which are being moving in the medium will not start all at a time. All the particles will not will not be moving at a time. All the particles will not start at a time. So firstly the medium has to be elastic in nature, and then the particles which are moving in the medium or the particles which have been disturbed in the medium will not start at a time. The next one, the third one should be, as we have seen here, it should have a periodicity. Then there should be, particles should have periodicity and should be alternative in nature. So these are the most important characteristics of a medium if particular medium has to execute a wave motion. If a particular medium has to execute a wave motion, that particular medium has to be this characteristic. This particular medium has to execute this particular characteristics. The first characteristics of a medium should be, it should be elastic in nature. Then the particles which have been disturbed in the medium will not be starting all at a time. And the third one will be, particles should have periodicity, and also it should be alternative in nature. So coming back to the second point, in the previous lecture we have studied that how the particles will not be starting at a time. We have taken an example of 4 different particles. When the one particle has been disturbed, then the second particle will be disturbed. One after the other, the particle disturbance takes place. If you want to understand the concept of this particular second part, you please refer the previous lecture also. If you please kindly note it down. Okay, students. Now we'll try to study about different types of mechanical waves. In the previous class or lecture, we have studied about what is mechanical wave. So we know that mechanical wave is nothing else but it is a wave which is produced, or the disturbance which is produced with respect to a medium. So definitely a mechanical wave requires a medium. Now we will try to study about what are the different types of the mechanical waves. Now these mechanical waves are being classified into two different types. The first one is called as a transverse wave, and second one is called as a longitudinal wave. First one is called as a transverse wave and the second one is called as a longitudinal wave. So now we'll study what is a transverse wave. Before entering into this concept of transverse wave, first I want to give a small example in order to make you understand what is meant by transverse wave. See, nowadays if you go to a fitness center or a gym, we find a kind of instrument, or we find a kind of equipment called as a rope. Mostly many people will be working out by doing the up and down of the rope. So that particular motion of that particular rope can be one of the example of a transverse wave. What happens in the transverse wave? One end of the rope will be connected to a fixed end, the other end of the ropes will be in hands of the person who is working on that particular exercise. Whenever he tries to pull that rope, what happens? The rope will be moving in an up and down position, or it will move in an up and down motion. So that up and down motion will be perpendicular. It will be perpendicular to the air, because here our medium is air. So now the motion of the rope will be perpendicular to the air. So I can say that this perpendicular motion which is caused by the rope is called as a transverse wave. So here, let us see here. Let us assume that these two fixed ends are there. One of the end is where the rope is being connected, and the other end is nothing else but the person who is been operating that particular rope. So once what happens? If a rope is moving, it goes in this upside down direction. Let me assume that this dotted line is the stillness of the rope before being operated. So once the rope is being operated by person who is handling this rope, then that particular rope goes in an upside down direction. This upside down direction, if you see this, let me consider that this rope is now operating in a air as a medium. Let me consider this shaded part as air as a medium. Now, if air is a medium, the rope is moving in an upside down direction. So now we can see that this particular motion of a wave is perpendicular to this. It is perpendicular to this medium. So the motion of the wave here is perpendicular to the medium. So we can say that transverse wave is nothing else but whenever the particles in a medium which are moving in the medium are perpendicular to the direction of the medium is called as a transverse wave. The wave which is being produced due to the disturbance of a particle which are perpendicular to the direction of the medium is called as a transverse wave. So the transverse wave definition can be the wave which is produced due to the disturbances of particles perpendicular or 90° or at 90° angle to the direction of medium is called transverse wave. what is transverse wave? Whenever a wave is being disturbed or whenever the particles in the medium are being disturbed, then that particular particles will be moving perpendicular to the direction of a medium. Perpendicular is nothing else but it can be a 90-degree angle, or simply we can call it as a right angle. Whenever the particles which are moving, whenever the particles are moving at a right angle to the medium direction, then we call it as a transverse wave. Now coming to the important parts of this transverse wave. If I consider this wave over here, if I consider a wave like this, then definitely it has got one maximum point over here and maximum point over here. So, but initially if I see this point from the point of axis, this will be the positive side and this will be the negative side. Okay, then I can say that this can be an elevation and this can be a depression of the wave. So this is an elevation of the wave which is in the positive side, or else I can call it as a maximum point of the wave in the positive side as an elevation, and the depression can be called as a maximum point of the wave in the negative side. So now here, if I consider these 2 points, the maximum point of the wave in the positive side is called as a crest. It is called as a crest, which is denoted by C. So this one is a crest. C. And the maximum point in the negative side, or else the depression in the negative side, I call it as a trough, which is denoted by capital T. Even this is a trough. So now in this particular wave which you are drawn on the board, it has got 2 crests and 2 trough. The crest is nothing else but what is a crest? It is a maximum point of the wave in the positive side of the waveform, or else it is a elevation of a wave in the positive side. And crest can be the maximum point in the negative side, or else it can be a depression of a wave in the negative side. So now it has got 2 crests and 2 trough. Now here we will study about a term called wavelength, which is denoted by lambda. Now what is meant by wavelength? Wavelength is nothing else but it is a time period between 2 successive crests or 2 successive troughs, or the portion between, or I can simply say it's a portion between 2 successive crests or 2 successive troughs is called as a wavelength, which has been denoted by a lambda. Kindly note it down. Okay, now we'll try to define what is crest and what is trough. First one is crest. It is a maximum point of the elevation of a wave traveling in a medium. So crest is nothing else but it's the maximum point of the elevation of a wave traveling in a medium. The next one, trough. It is the lowest point of the depression of a wave traveling in a medium. So these are the two different examples of two different definitions of what is crest and what is a trough. So crest is nothing else but it is a maximum point of elevation of the wave traveling in a medium, and trough is nothing else but it is a lowest point of depression of a wave traveling in a medium. So crest is nothing else but the maximum point which you can see in this wave is called as a crest, and the lowest point which we can see in the wave is called as a trough. And the time period which is in between these two successive crests or successive trough is called as a wavelength. So wavelength we define here as the time period between two successive crests or two successive troughs is called as a wavelength, which is denoted by lambda. So wavelength is nothing else but it is the time period between two successive crests or two successive troughs is denoted as a wavelength, which is denoted by lambda. Or simply you can remember this point as the portion which is between two successive crests or the portion between these two successive troughs is called as a wavelength. Can you note down these definitions of three terminologies? First one is crest, second one is trough, and the third one which you have seen over here is wavelength.